Numerical 5.8. At what altitude the value of G would becomes 1/4 on the surface of Earth? So first of all, we write here the value of given data, value of gravitational acceleration, gravitational acceleration equals to 1/4 and its value is 10 the fourth, and it becomes equals to 2.5 meter per square second. Mass of Earth is equals to 6.0 multiplied 10 raised to power 24 kg. Radius of Earth six 400 multiply 10 raised to power 3 meter. Gravitational constant capital G is equals to 6.673 multiplied 10 raised to power minus 11 Newton meter square per kilogram square. We have to find the height, altitude. Height we have to find. For this we will use the formula of G. Height is equals to G M R plus H whole square. Now we will rearrange the formula because we have to find out the height. R plus H whole square is equals to G M A over gravitational acceleration. To remove the square, we will take square root on both sides of the equation. R plus H G M A will take square root on both sides of the equation. Square with cancel with the square root. Remaining value R plus H is equals to G M E over G. We have to find out the value of height. So height is equals to G M E over G minus R. R we will write in this side. So the plus value will be changed into minus value. Now we will put the values inside the formula. H is equals to the value of G 6.67 multiplied 10 raised to power minus 11. Value of M 6.0 multiplied 10 raised to power 24. And the value of G 2.5. And the value of R 6400 multiplied 10 raised to power 3. Now we will solve this. It will becomes equals to 625222725. So we will move the decimal 1 2 3 4 5 6 till here. So it will becomes equals to 6.0 multiplied 10 raised to power 6. And this value is approximately equals to 1 Earth radius. Numerical 5.9. A polar satellite is launched at 850 km above the Earth. Find the orbital speed. Given data, the height of satellite is given, that is 850 km. Is equals to 850 km. We have to find the orbital speed of the satellite. Orbital speed of satellite we have to find out. For this we will use formula for orbital speed, that is equals to g h r plus h. Now we will put the value of g here. G, that is equals to g m e r plus h square. Remaining value r plus h. Now we will cancel this 2 with this. Now the remaining formula V naught is equals to g m e over r plus h. Now we will put the values inside the formula. G 6.67 multiplied 10 raised to power minus 11, m 6.0 multiplied 10 raised to power 24, radius of earth r 6400 multiplied 10 raised to power 3 plus height is given, that is 850 multiplied 10 raised to power 3. Now we will find its answer. Its answer will be 7431 meter per second. Numerical 5.10. A communication satellite is launched at 42000 km above Earth. Find its orbital speed. So first of all we will write here the value of given data. Height is given, so that is equals to height 420 multiplied 10 raised to power 3 meter. We have to find the orbital speed. Orbital speed that we have to find. We will use the formula V naught is equals to g h r plus h. We will put the value of g, becomes equals to g m e r plus h square. R plus h, this square will cancel with this. Now the remaining formula is g m e r plus h. Now we will put the values inside the formula. Value of g 6.67 multiplied 10 raised to power minus 11, mass 6.0 multiplied 10 raised to power 24. Value of r 6400 multiplied 10 raised to power 3 plus height 4200 multiplied 10 raised to power 3. Now we will find its answer. It is equals to 2876 meter per second.